Hello and welcome to Building Levels Procedurally and the Vertex Animation Toolsets with Houdini and Unity. So I'm Simon Verstraete. I've been working with SideFX, making tutorials for game engines. So the first thing I'm going to talk about will be generating levels with Houdini. So in Unity, I will have a tool and the tool generates a level. So we'll talk a bit about how that works, how an artist would use it, how a technical artist would use it, and so on. And in the second part, we'll be talking about the Vertex Animation Toolsets on bringing in complex simulations inside of game engines like Unity. So of course, the first part will be making the levels. And for that, I'm actually going to use something which I made before, which is the sci-fi level tool. So this is something that I made a while ago. And from one single curve, we can actually generate something like you see here, like this image. So this also has a full tutorial background. So every single thing you see has a tutorial behind it. So for example, the crater on the left, there is a tutorial for making procedural grade. So here in Unity, I have my tool open. So this is actually a example or a blockout example of the tool. So the tool itself will make a level that looks like this, but of course the visuals are now in the blockout. So a technical artist would make something like this. Something that works in functionality, but visually is just something that looks like a blockout shape, if not any assets are provided by artists, for example. So let's take a quick look here. So we have a level, so we can follow this corridor, and then we sort of like come here to an end, and I have this big prop here sitting at the end. I can go here to the other direction. I have some things here and there placed automatically, and I have another prop here. So let's take a look at the models actually used by the tool. So here on the sides, I have my modular kit. So the tool works on a modular kit. So the technical artist would use this modular kit to place them next to each other. On the shape, we will place it, the corner piece that I have here on the corners, we will place the ceiling part where we want the ceiling, and so on and so on. So this is what I will have here. So the Houdini artist, the technical artist can already start working and building the core system of the tool. But also the environment artist can also now use these blockout shapes to already start refining the look of the scene. So from here, we can already like fully start building this. If you're working in a studio, if you're, for example, working in a more indie studio where you have to do everything yourself, then starting from a blockout is actually just recommended, so you have some feel of how the procedural assets will be placed without having any too much work on the asset itself. Also, what I did not mention is also this small thing over here. So we have these 4 models, and these 4 models are randomly placed on the wall. So if I go back here, we have a system in place that randomly places these on the wall. So you can see that they sort of like try to fit in a specific direction, so they nicely fit in here. So with that said, let's now look at the tool itself. So for that, I already make something in preparation. So I quickly made these models. So again, from the modular kit, you will make something that looks a bit more final like this. So with that, also here, I have some prefabs for that. So again, just some basic prefabs that I will use in a moment. So now if my Houdini engine is activated, I can make a level like this, like something you see here. So all the models are just placed for me, and the level could look something like this. So let's start from scratch. So let's say you need to build a new level for your game. So what you could do is you go to your assets. So my Houdini asset is here, and I can just drag and drop this in the scene. So after it's been warmed up, it's gonna look like this. So let me just drag it over here. So right now it's not really outputting any special, it's just outputting this basic ground shape of my level. So the random curve you draw can be quite random, and it will sort of try to clean it up a bit and create a nice structure for the scene. Now by default, if we go to the model tabs, I have not assigned any models by default. It is possible to assign models by default. I actually showed that in the other talk before this one. But for now, I actually just left it blank. So you have the option to manually say, I want this model, I want that model. So you actually have some more control in what's going to result here in output. Now, before I assign my models, I'm actually going to here toggle my building mode. So let's click building mode. And you can see that my output now changes to this geometry. So instead of the plane now, I actually have something like this, which is very basic. So the reason I have this is because building mode is fast. If I now go to editor mode and I grab one of the points here, we can see that we almost have an instant result here. Like it's very responsive. So I can now start building my level. So let's say I want like a small level here. We can also add points. So click on add here. And we can now start adding different shapes here. So let's make something like this. And we can always go back to editing. Let's say maybe this needs to be like a perfect square. Maybe this could be longer and things like that. So we can just play around with that and make an interesting shape for my level. So once we have that in place, I have made a base layout for my level. Let's now actually assign the models. So again, I'm going to disable building mode since I've done building my level, and I'm going to assign the models now in my model slot. So I already made the prefabs as I mentioned. So prefabs, I have custom prefabs, and I'm going to use them. So in my wall, for example, base wall, I'm going to just grab my base wall in here and it will place them for me. So you will see that bit by bit, my level will be built based on the modules I put into it. We also don't have to force this. Like, for example, I currently don't have a door model yet, so I don't have to use that one. So let me keep building here on that. So here we have another model. Here we have the small wall. Then we have another small wall. Then we have here the wall with the random pieces. So these are the random pieces. So I quickly made a couple random pieces in Houdini. So 2 by 1. So what is special about these random pieces is they have a specific unit. So they are 2 by 1 units. So they need to be in that unit range because it's in the tool. It is actually made for that unit range. Because that's of course a bit easier to work with if you know the units. So we have that now in place and also have a couple corners. So we have the concave and also we have a convex corner. So now we have this level. So these are the basic props you can add. You can also add more things here and there. But now we have a basic level here, which is already looking pretty cool. So now some of the settings we can play around with. So of course you can add as much settings as you want. Like if you have already seen a bit things about Houdini, you can make the tool in settings as much as you want. In this case, I kept it quite simple since I don't want to like overwhelm someone with like hundreds of parameters. So we have a basic seed slider. So these are specifically for the wall. So we have different variation here. So the greebling is sometimes here, or sometimes it's just a normal wall. Then we also have a slider for a complexity. So my wall is sometimes this basic wall system that I made. So this base wall, and sometimes it's just this greeble wall. So let's say I want the ratio between these two walls to be less. So I want to see more of the normal wall. So I'm going to increase this here, which will be increasing that ratio. So now I actually have less of those complicated wall systems. And then also here we can rotate this one. So you could see that it looks nice, but it actually needs to be rotated inwards. So we can rotate the wall here with like maybe a little bit less, like 15 degrees, like so. And we can also have a position variation. So if I increase this, you will see that the variation of each piece, as you can see, will be a bit different in place. And we can also maybe lower this bit back again and push in the pieces. Maybe not that much, like so. Maybe just 1 - 1. So we are just pushing in those pieces a bit more, so it's not like coming out too much and interrupting with the view. So we have something like that. So this looks quite interesting. And again, we can just play around with like different seed sliders and other parameters we have available to have more variation in the scene. So now again, this is also just placing modular assets. And if we look at the hierarchy, this is all still prefabs. These are all still linking back to my original prefabs. So if, for example, now let's just grab here this box, and I can, for example, just go into this prefab mode where you can, for example, scale this up or scale this down. So let's say I want to like scale this a bit downwards. We will see that all the other pieces are also being scaled down. So everything is still linked to each other, which is of course super useful. So I can be quite quickly in making this, and I can always just jump in the prefabs and tweak this until it like fits the best for my scene. So once we are done generating this, what is actually recommended doing is baking out results. So again, when I talk about like, for example, trying to generate bigger parts of the scene, like 70%, 80% could be generated, and then 20% or 30% could be more like manual tweaks for gameplay, for quests, or for story-wise, that you might want to do it a bit more manually. So what we want to do with this is, once we know that this is going to be close to a final result, we can either bake to game object, we can bake this into one prefab, or we can just say keep output only, which basically is going to remove the Houdini engine data and its components. So it will basically remove this whole menu and some components here inside. So we don't have to deal with the Houdini engine and for example, this curve and so on. So that is just again recommended doing. If you know you're close to something a bit more final, bake out the results, and an artist could easily start to tweak and move things around. So they could easily just grab the wall, place it somewhere else, make something like a small room here for a quest or for a gameplay. So if I now would sort of like rebuild my tool, it's just gonna like force those back in place again. So that's why it's interesting to bake out the results. So you can easily override those things. So now I did a lot of talking about this tool, but I also want to give you some background information about how this is being created. So we'll jump into Houdini and recreate the base setup. Again, we have tutorials for this. So we have the sci-fi series covering a lot of different things, but I'm just going to try to only like cover the very basic idea of placing walls along this curve. So one of the base ideas or setups for this tool is to use a curve. So I'm going to just create a geometry network to, of course, have geometry, and I'm going to add a curve in there, just a basic curve. And I'm going to draw a curve. So I'm going to zoom out on my grid until I see something like 50 units like this, so we're not too much zoomed out. And we can draw a quite random curve. It doesn't have to be specific size, it could just be like this. We could even do a crossing here and press enter. So we have this quite random curve. So now it actually is, the curve has been made in the viewer camera view mode, so it's been created in that way. So one of the main things that I did here is to actually force this to be a flat surface. So here I'm going to just place a transform node, and we're going to just say scale 0. So it's actually facing back here in one single plane. Now from that, what I'm going to do is I'm going to resample the curve. So resample will actually add a lot of different points on the curve, as you can see. These are all single points. So there will be a lot of them. And with those points now available, I want to snap points to a grid. So I want to get control over the curve. So since I allowed the users to have a quite random curve, like they could really just draw a very random curve, I want to get back control by making a fuse on grid. So we can use the fuse node. And in there, we have options, and we're going to use the grid option. And what we're going to do in the grid option is we're going to set the spacing. So the spacing could, for example, be 5 units, 10 units, or for example, even 8 units. And you can see that by filling that in, we are just sort of like making the curve more controlled. So we sort of still have that shape of the curve, but a bit more in a controlled way that is actually usable for my tool. Now on that curve, what I want to do next is I want to copy a grid. So a grid is just or a plane. I want to copy this, so copy to points. So I can copy the grids on the points. So this will be sort of like my ground plane or the blueprint of my level. But I also noticed that since my spacing was 8 by 8 by 8, my grid also needs to be actually also 8. So it actually nicely aligns. As you can see now, it actually nicely aligns there. So now we have that grid here. So this is the floor plan or the ground plan of my level. And what I want to do next is then actually sort of like get the edge or the border and place around walls on that border. So next step would be also fusing the shape back again. So what is actually happening now is that this is not one solid shape. This is actually all those grids next to each other, but they're not like merged into one shape. So we're going to fuse them. And when I fuse them, this is actually now one big shape. So after that, we're going to then also clean up the shape. So we have a lot of like topology here. So what we can do is we can flatten edges, which is a labs tool. So make sure you have labs installed, and it will create something like this. So from that, we have our base floor. So in the tutorial, if you would follow that, I would actually place a null node here because this is a very important part. This is sort of like my blueprint or the ground floor level where everything comes from. So this is one of the most important parts of the system where we're going to decide what comes from next. So from this information here that I have now, I can build a wall, so I can figure out where to place my walls. So here on the edges will be my walls. Let's say I want to, for example, scatter around props. I can also use this information for placing props because the area here is all walkable. So I could, for example, scatter props here in this path. I can also use this for a floor system or a ceiling system or placing lights. So from this, I can do a lot of different things that will be just very useful. So for now, I'm just going to focus on placing a couple of walls here and there. So what will I do? So from that, I'm going to just use an extrude node. So poly extrude. And in here, we're going to just extrude up the shape with the distance. And we're going to fill in number 8. So I'm going to be quite consistent with number 8 since I used it here for my grid. So now it's actually all like square boxes. And what I'm mainly looking out for now is the walls. So in our output settings, we can actually say don't output the front group. So we actually now have the walls only. So this is very interesting now to work with. Now, next step here is we need to resample this back again. So one of the reasons why I resample is because I would like to have more points on the geometry. So again, resampling will add lines will add points to a line, as you can see. But I want to specifically add a certain length. So if I fill in number 8, it will again line up with that grid spacing that I did. So if I quickly jump here into Unity, we actually had two walls. So I had a large wall and a small wall. So the large wall is actually having the ratio 1:1. So it has some 8 units by 8 units in my Houdini setup right now. And then the smaller one will have 8 by 4. So it will be half of that unit. So what we can do here with my resample, if I set this to number 4, it will now be having the small walls. So this is, for example, one small wall, and 2 of those blocks are on one big wall. Now, next step, what I want to do is I want to extract the points. So again, I want to copy my modular kits on the points. So I want to extract the bottom points here. So for example, I want to extract these points from my wall to actually copy the real model on them. So that's what I'm going to do next. So I'm going to try to extract those points at the bottom. So what we can do first is delete the corner systems or the corner points. So we can use a group node. And in the group, we can just, for example, name this corners. And we can switch this to a edge mode. So disable everything except for edges here. And we're going to enable here minimum edge length angle. But now it's actually not really working. And one of the reasons is we need to fuse the shape back again. So the resample broke up the primitives from each other. So with the fuse, we bring that back to into each other. So now we have those edges. So again, we need that fuse here in place to make sure those shapes are seen as one. So we can easily extract that. And now to delete that, we can use the blast node. So blasting is deleting those spaces or those shapes. So we can fill in the corner group. And now we have actually the walls or the flat parts of the walls. So now the only thing left here is to actually extract the bottom parts, which I can also do with a group node. So again, placing group nodes, and this will then, for example, just be bottom points, for example. And what we want to do is we want to select the points. So I'm going to switch this to points, and I'm going to use the bounding box feature. So enable bounding box. And with that, I want to input a custom bounding box. So the second input here is for a custom shape. So what if I, from this floor blueprint, make a poly wire? And with this poly wire, if we increase the radius here, we will actually add, as you could see, this shape here. So we'll sort of like sweep on that shape. So let's put that in over here. And we're gonna now say bound by object. And now it will be able to select that parts. So now again, same as before, blast the things that we don't need. So we're gonna say blast based on the bottom group, and we want to reverse that. So we actually have the bottom points. So now I have everything in place. So now I have all the locations of where walls could be. So I could also now improve on this, but let's visualize this already. So we're gonna say copy to points. And let's also grab a test object, so the pig head, and let's place it in over here. So now I've copied the pig head on those points. So what I can see now is that the placement is good, but the rotation is off. So they are all facing the same direction. So of course I don't want that. I want them to be in a certain logic. So we can quickly fix this here by going back to our shapes over here, and we can actually use a normal. So the normal, if we say point normal, will actually add a direction to those points. So each single point has a direction where the model should be facing or where the primitive is currently facing. So after we do our whole filtering out the corners and the bottom points, we still have those points here with normals. So again, this is very important to have. So it's the direction, and if I now copy my big heads on that, we can see that they are now in a better direction. Now, only thing here that we could tweak, for example, is that they should be facing each other. So this would be a corridor, so we could quickly do another normal. And we could say, don't compute a normal, but just reverse the normal. So we can just reverse that. And this is basically then my wall system. So of course you want to load in your own model. So you can either, for example, use the file node to load in a custom geometry. Or in this case, we can also just use a box for quickly visualizing this. So let me just grab the box here and do something like this. So we can quickly make like a very basic level layout. So these are all now modular parts. So there are some more systems involved where we can automatically switch between the large model and the small model, but I'm not going to explain that here. There's not enough time to like explain everything in detail. But again, there are tutorials for this. There is like a whole tutorial about every single detail about this tool. If you're interested, you can watch that video. But basically here we are done. So only thing left would be, for example, merging the results. So we have the ground plane with our wall system here. So we have this, and now I can always go back to my curve, and I can, for example, now grab this part here and play around with that. And I can also start building a level here. So this is the base setup of that level builder tool, very quickly explained with some basic ideas and concept here. Let's now jump into the next part, or the second part of this talk. So I want to show you Vertex Animation Textures. This is a very cool feature to bring in a certain complex simulation or setup made in Houdini, and you can then use that in Unity. So if you do a sort of like fluid simulation, you can bring that from Houdini in Unity based on textures. So that's also the name, Vertex Animation Textures. So before I actually start to jump into the project and show you some of these examples and how they are built, I want to give you some little bit background information on this. So overall, what is Vertex Animation Textures, or VAT in short? So it's a technique where we break down the animation of a mesh into textures. So usually we have, for example, our timeline with animation. So we're going to save that into a texture. So the texture is then used in a vertex shader in a game like Unity to then drive the points of that mesh to a certain position to move over time. So the texture you see here on the screen is actually an example of that. So for us as viewer, it might look like a very random texture where each pixel has like a very random color. So it's important that each pixel has actually a certain value that will contribute to that animation. Then Vertex animations further, they don't use bones. So often when we animate something for a game, we will often use something with bones. If I have a character, it's going to be character have bones, we're going to animate with the bones and so on. So, but with our case, with Vertex animations, if you again bring in a certain, like a simulation of a fluid, we need a mesh and we need to have the texture to say what the points over time need to be doing. So with that, we sort of like have control over each vertex of that mesh with a shader. So we can specifically say what a certain point needs to do over time and how it should be moving, which allows us to have some bit more control versus the bone-based methods we are often using. We just attach or assign a certain weight to bones with the points. Now, if we take a look at the texture itself right now, it can look something like this. So it depends, of course, on what information you want to export. Like you can, of course, export position. You can export, for example, just the rotation or the color of a mesh. That could also be exported. So let's say here this is a texture for the position. So the texture itself will have the point numbers. So it knows what to do with each pixel on the point. And it will also have then the frame numbers in the height. So each pixel here is very important. It holds important data to drive to drive the model in the shader. Of course, if we take a look at this, if I have a model that is quite high in poly count, our texture will get bigger. If I have a model or a simulation that has multiple number of frames, or like a very large number of frames, my texture will also be getting bigger. And that's something you always have to take in consideration here. If I have something like a very complex simulation, we will need a bigger texture for that. If I have a simulation that is very simplistic, we will have a very small texture for that. So that's just interesting to know on how this works. So high poly counts, high number of frames will of course increase that texture. So that's something to look out for. Now in Houdini itself, we have 4 methods of exporting, or 4 different modes you could use. So each mode represents a certain simulation setup. So we have soft bodies, rigid body dynamics, dynamic remeshing, and particle sprites. In a moment I will show you each example in Unity and Houdini, but know that these are quite important to know about. So each mode again represents a certain way of working. So if I do a clot simulation or a fluid simulation or destroy something, they will all use a different type of method. So the textures will also represent different data. Now let's look at some high-end examples here. So these are again high-end examples, so they are quite high in texture size, but they give a really cool result. So this is a fluid example. So we're going to throw fluid orbs at an object, and we can see that we can get a quite high amount of quality. So we have like a real feel of the fluid in here, and it also has the colors in there. So the colors are also stored in that Vertex Animation Textures. So we can get a lot of like interesting data from Houdini inside of Unity, for example, here. So again, it's a quite high-end demo, but if you need this in a cinematic, this might be worth exploring this technique. Then another example is a bit more advanced. This is sort of like a metal cage, and it is actually sort of like being destroyed by this bar. So this is again all Vertex Animation toolsets. So it's just like quite high-end, high-quality destruction of a metal crate, which is quite impressive here to have that actually real time. Then another demo here is this building, and this is a demo of destruction. So here, this house is fully destroyable or baked out into mesh, baked out into textures. So we can see that we have a quite high amount of data here. So we have this super realistic destruction of a house. So again, this probably needs a quite high amount of textures, since there are a lot of like individual pieces. So basically with this mode, each piece has its pivot, and the pivot gets stored into textures. So there will be a lot of like different pivots, so the texture will be quite high. So it won't be like a 500 by 500 texture. We are speaking about 2000 or even higher than that, based on how many pieces we are having here. Then another example here quickly is then particles. So if we do a certain particle setup in Houdini and I would like to bring that to Unity, we could use Vertex Animation tools. So this just, again, based on textures, we're going to move those geometries. And we can also export specific data. So if in Houdini I have a specific velocity that I want to export, or density or color, we can save that into textures and then have it converted here in the shader. So those are some examples. Now I'm going to show you some more basic examples, and I'm going to use here files from a tutorial. So this is fully being documented again with tutorials. So if you're interested in Vertex Animation Textures, we have full tutorials on that. So from the starting point, what is this? How do I install all of these tools? What is a soft body, rigid body, fluid body, particles, like how do I use all these kind of different things? So in a moment here, I'm going to also show you these things as well. But of course, the tutorials will go a bit more in depth and so on. And you can also find example files here as well. So here I'm in Unity now, and this is a small scene, or the scene from the tutorial setup. So we have the 4 different types of Vertex Animation Textures supported in Houdini. And we're gonna start out here with the clot here. So this clot example. So we can do a quite interesting clot simulation in Houdini. And we can convert that here in Unity. So this is a cloth tearing apart or breaking apart by a certain object that flies through it. So this is a quite interesting thing to set up and to bring in here. So a few things before we start. I'm currently also using a quite recent version of Unity. So I'm actually on the 2022 alpha version, because there are some features specifically used here with Vertex Animation Textures, especially like in the shader graph. We have actually support for multiple versions of Houdini, like 2019, 2020, 21. So do we have support for multiple of them? So based on the version you use, you have to do a different installation or grab different shaders for that. So, but I recommend you actually trying to get the most recent version if you can. So the setup itself here, so we actually have a mesh with a special texture. So again, the shaders are built for you, so you don't have to make a shader for this. And the only thing for us to do here is to actually fill in the texture. So again, we have a texture for the position, we have a texture for the rotation, and for the color. So these are the outputs of that tool. So what I only have to do here in Unity is to import my mesh, textures, set up the shader, and it's done. So you only have to do those things. Now, if we take a closer look now in Houdini, I have some of these setups here available. So let me take a look at the cloth example. So the cloth itself is just starting from a basic plane, and we're gonna make sure we have some more topology to work with, so we can actually simulate this. And I'm also gonna add the fracturing parts. So here, if I quickly enable here the visualizer, we are actually sort of like splitting up the mesh into multiple parts. And this is then being used for breaking or fracturing the cloth. So furthermore, we then do some properties of the cloth. So we have the cloth constraining node, which is just basically defining what this type of geometry is. So we just say it's a cloth. We can assign different thickness, the weight of this cloth, how stretchy the cloth should be. We can also here, for example, use the pin animation group. So these are parts that should not be animated. So we can say that my cloth needs to be attached to the wall. So we can then plug in a group in here. And then a part here for the breaking part, we need to actually use instead of the cloth type, we now use a weld point type. And all the way at the bottom here, we can actually enable breaking. So that's quite interesting to play around with. So in the simulation now, I have my cloth, but I also have a sphere here that is being seen as my collider. So if I move the timeline, you can see that my sphere is just moving up and down over time. So then in the actual solving of this, when my sphere is going to move down, it's going to push through the cloth and then tear it apart. So we have that breaking effect here going on. And you can clearly see that the fracturing that we did earlier will also be respected here. So based on that refracturing here that we did, we will have a different result. So if I now would play around with how many of these fractured pieces we have, it will also do a different simulation. But I quite like how this looks. So now that is done, so our simulation is basically done. You can add more effects on this, but what you should output is just this. So you just often would place a null node here. And now we are going to go to the output tab. So I already have it open here, different outputs here. So the output tab here is just available. So normally you are on object level, like here I'm on object level, but now we can just go to the output level. And in the output level, we actually find our tool for the Vertex Animation toolset. So here, Vertex Animation Tools. So we can place the node here. And then we can define what we want to do. So one of the first things to do here is what type of simulation is this? So again, we have those 4 modes. So I'm working with Vellum, with cloth, which is actually a soft body. So we're going to say soft body. Then we're going to say the game engine, so Unity here. We can say the starting and ending frame. So if you need less frames, you fill in less frames. It's automatically just looking at what you have here. So again, keep in mind that the more frames, the higher your texture. So that might be interesting to always keep in mind. Then we have here the input geometry. So we're going to take a reference here to my object level. I'm going to grab my clot and I'm going to grab my clot sim. So this is that null node that I placed here. So this will now be referenced or linked to my Vertex Animation node. So it holds now that information. Then further down here, we have some different settings we can play around with. So if you need like very specific data, you can then here also add that data. But one of the interesting things to keep in mind that we are exporting an HDR texture, which is actually a 16-bit texture. So we need that extra bit to actually have a quite accurate result. If it's possible that you want this to be like an 8-bit, then you can also change this to non-HDR, but then you also have to make sure in your game engine, you're also setting that to non-HDR things and so on. There are further some more settings we can play around with. I'm not going to go over every one of them. Here we have a target texture to aim for, but often I leave everything at default because it does actually a really good job at outputting some textures for us. Here we also have the input tab. So this is actually interesting to read the requirements here. So what is required for this tool to work is that each point has a position information. So of course, by default it has. That should not be a problem. Then we have the export. So where do I export this tool? You can then fill in a custom location. And also very useful to know is that by default, it will export a Unity material. So that's really interesting. So I don't even have to create that shader or material. It will actually output one for us. There are some more settings we can play around with. Also interesting here is the real-time shaders. You can actually get the Unity package here. If you click the button, it will guide you to the location where you could find it. So if you're not sure on how to get that, click the button and you will get that information. So once everything is set up, what we're going to do is then we're going to click the render button. So once we are rendering this out, one of my results will look like this. So we will have a folder structure. So we will have our geometry. So just our mesh. Then we will have our textures. So by default, there will be these three. So color, position, and rotation texture. And then we also, especially here for Unity, have a Unity material. So you can just drag all of this into your Unity project and you're almost good to go. So in Unity itself, we then have here, if we go to our soft bodies here, so we have that in the exact same folder structure. So I have my geometry, texture, and my Unity material. So important here will be actually import settings. There are some presets you could use as well. So you need to have some specific changes here. So we are, for example, importing custom tangents. So don't calculate them. And there's some other settings you do for you to change. Also the textures, we're gonna have to make sure they are having a specific settings here. For example, don't do any of the power of 2 here. Make sure that it doesn't really change too much data. Because again, with these textures, every single pixel holds information. So if we have a setting here that will change some of that data, it will also reflect, of course, in the Vertex animation to not be fully correct. So once we have that correctly imported, we can then go to our material. And here, the only thing we have to do is fill in the textures. So everything else, for example, like the FPS, or for example, the bounds of my simulation will be automatically being filled in for us. So that's how we're gonna use that and set that up. So once that is all working, we can then grab our model and apply our shader, and then we have the same result from Houdini inside of Unity here. So for you who are more interested in the shader part, we can here go to our shaders and start to edit them. So this is our main shader for the soft body. So again, for each different mode, we will have a different shader because some of the data is handled or calculated differently. What you will find with most of these graphs is that the sort of like the center is like this one big node, which is actually doing sort of like the calculation for it. So again, you can jump in this node as well, and you can try to look into this, understand this, or modify this. It depends on how deep you want to go in all of these vertex animations. But again, by default, you should not be worried about this shader thing. It should just work out of the box here. So what is important here, or important with the newer versions, is that we now have this custom interpolator. So we have data here on the vertex, and we're going to use a custom interpolator to then convert that, for example, here the color to fragments, to actually here an interpolator, so we can use it here in the fragment. So here I'm actually just overriding the cloth with a blue color, so you don't have to use them. You can always just override as much as you want, but by default you, for example, have this available, and then my color of my cloth currently is just this white color, so it's not that interesting. So I actually override it and made it blue. So that's how some of that information works here. Then next step, let's start looking at some of the other examples. So here I have the destruction. So this is a rigid body simulation, and you can see that I have a quite high amount of pieces, or a decent amount of pieces. It's not super high, and it's all just now being played automatically here in the scene. So we have some debris and we have some wooden pieces. So again, it's the same setup as with the cloth. So we again, if I would open my project here, examples, we can have the same folder structure. So I have a geometry, I have my textures, and then I apply those textures to the material here to know how the mesh should react to it. And then we can use that on my mesh. So let's now take a quick look in Houdini. So here in Houdini, let's jump back to my rigid body. So here I have a small setup to calculate this thingy here. So let me start quickly at the beginning. So I made a box for my wall. Then I do a material fracturing node, which will break up the box into fractures or pieces. Then I will do the same again. And actually this time I do it for wood. So now we're actually going to create something that looks a bit more like wood structure. So now we have basically this result. So I have a concrete wall and I have a wooden wall layered on top. Then I'm going to just align it on the grid. I'm going to assemble this into packed geometry, and I'm going to assign a velocity to each packed geometry. So point velocity will just assign a velocity amount to that. So the velocity is then used to then, in the simulation, push the pieces away. Now I'm also going to use a group which is called active. So everything here inside of this sphere here that is now green will be seen as simulation, or seen as a something that could be flying away and is dynamic and not static. Now, to make sure we are converting that inside of the solver, I'm going to create a group called active, or an attribute called active, and I'm going to set it to 1. And this is going to be also based on the group. So now inside of my solver here, sort of like all the information I created here is then combined to create this effect. So we have this wall breaking up. So again, if I want to change this, I can always go back to, for example, my velocity. I can add more velocity, I can add less velocity, and so on. So you can play around with that. Then we're going to do the same thing as before. So I have my simulation. If you are doing something more complex, I recommend you, of course, caching out your simulation. Since this is not super complex, I just placed a null node. And again, the null node is then referenced back here again to a labs node. So here again, we are referencing back that null node for my destruction. And then we'll make sure you are using the rigid body mode for rigid body now. A little detail here is that we also need to make sure that we include an orient and a pivot attribute. This is very important for the Vertex Animation Textures because this will actually be stored in textures. So if we go here to my node And if you look into inputs, it's required to have a position, a pivot, and an orient information. So if you don't have these three available, the tool will give you an error and it will tell you that you need to make sure you have that available. So for my case, I need to actually make sure I'm transferring those information so I can actually calculate that texture. And again, if everything goes right, we can just open everything in Unity, and then we have here everything available to make something like this. Now then, let's go and look at the sprite. So I'm going to keep the fluid for last. So here we have the sprite, or the particle one. And right now, this is like a very basic example that I made. And it's again the same thing as before. So we have here our geometry. And in this case, it might look just like this. So our geometry is quite funny here. Then again, we have our textures. So we have these two textures here available. And we have then also here that shader. So here with the shader, it only needs, for example, the position and the color to work. And there are also, of course, some changes you could do. Like I can always afterwards multiply. As you can see, I can always play around with some of these settings. I can make them like very little particle effects. I can make them a bit bigger. So sometimes it's a combination of both. Like you have some baked down information, but you also have some shader control here available. So that's how it looks. And now let's go into Houdini and talking a bit about the setup there. So here we're going to go back to my objects. Let me grab my sprite setup here. And let's talk a little bit about that one. So I started out with a sphere since I want sort of like this orb emitting particles. So I have this sphere, and on the sphere I'm scattering here a couple points. So these points are all emitters or starting points for the particle. And what I'm doing here is I'm just moving these points over time. Then further, what is interesting here is to use the trail node. Trail node is very useful. It's a cool node to play around with. So I'm using it to compute the velocity. So we'll store how or which direction we are actually going into. So there are two main informations to use in the solver. So we will have our points and our velocity. So then inside of this simulation network, we will actually create this effect. Now, what you can see also here, this is not really looping. So we have a node which we can make something a bit more loopable. So here, this is going to be more loopable as you saw in Unity. And furthermore, that's basically it. So we can still do some like tweaks on, for example, the scaling and so on. But we are basically done here also again for exporting. So again, same as before, we create a null node. We can go to our output. And then we just gonna fill in the null node over here, set the mode to particles, and then we can render it out to have our result. So we have here the result. And also for visualization, I recommend you just copying a shape on those points. Because currently here, what we are just seeing in our viewport are just single points, but they are not really like scaling up or down. So my actual point have scale information, and by copying a small shape on this, we can now visualize that scaling over time. So now we can actually see that some of my particles are scaling up and down over time to sort of like help make this also loopable in the scene. So again, this was the setup. So it's a basic setup. What is also interesting to know here is that we can also use custom shapes. So here we can, for example, draw custom shapes like this star and moon. And we can just say that we want to use that instead of the plain cards we had earlier. So that's also something interesting that you might want to look into. One small interesting thing here as well is that we can actually by default control the shape, what will be on the points. So by default, it's just a card as you saw in Unity. So here in Unity, this is actually just one single plane on each point. So as you could see, like these are just points or plane cards. So these are square cards. what we can do is we can change this to a triangle or hexagon. So this can have some advantages. And for example, triangle will be lower on the triangle count, less overshading. Hexagon, it will be a higher poly count, of course, but less transparency overdraw. So these might be interesting to then tweak or play around with. But of course, you can again use also your custom shapes, and then you basically will not have the option to use the square card, but then you have to input something like the star or moon shape as actually shape to copy this on. And now let's move on to the next example. So in Unity, let's go to my fluid example here. And here is a fluid simulation example. So again, same as before, we have our outputs here. So we have the geometry, we have our textures. This one actually has one more texture than the other ones. It has a lookup table, which I will talk a bit more about in a sec. And again, we just need to set up this material and it will work. So then we have a nice fluid simulation like so. So let me go into Houdini and talking a bit about that. So here is my fluids setup. So let's take a quick look at how this is done. So one of the main things that is happening here is that we have 3 sources of emission or starting points. So I just took these 3 spheres and placed them in that position. Then I'm going to say that these 3 spheres, they need to be a flip source. So they need to be a fluid emitting source. Then what I did is I assigned a direction to one of them. So you could see that we now have these arrows facing down. So this is where the fluid should be sort of like aiming to. So I used a big sphere to sort of transfer the direction from the sphere into those sources. Then I'm also going to say with a little bit of vex that my velocity is equal to the normal multiplied by 5. So we're just basically converting this blue arrow to my velocity. So then in a simulation, I also included some collision here. So I had some collision here on the side. And then we have this result here. So we have a small particle of like some fluid going into a glass, for example. So right now our information is basically points or particles right now, you could say. So we want to convert these to actual geometry. So we're going to use a node here to convert that to geometry, to an actual mesh. So again, here it's important to keep in mind that the higher we go in poly count, the higher our texture could be. So right now it's not too high, but I, for example, could easily make this higher by increasing those values here. And now I have a higher poly count, but also I have more detail now on these splashes. So that's something to always think about on how much should I actually use, or how much polygon should I spend where. So once you have converted this, we also importantly need to convert this to a surface polygon. So by default, it will be a surface polygon soup, but it needs to be a normal surface polygon. And that is because the amount of primitive numbers is 1. So we need to make sure that is an actual number. So we are done with our simulation. You can either cache it out, but I have just a null node here. And now again, same as before, we have the null node. And now we're going to use that here in our fluids, fill in our fluids, and we're going to say dynamic remeshing. Important here is that we have 2 passes. So these passes mean that we need to render this 2 times. So we're going to hit first pass, we're going to click render. After that is done, we're going to switch to second pass, hit render, and then we have all the information. So then you have this simulation all here inside of Unity. Now a little bonus here for everyone here who is watching the video is we could also, if you remember the small tower scene from my previous talk here, we could, for example, make something like this. So let me scale this up. So this was the tower that I made for the first demo on introduction. So here now we have this fluid coming from the tower. This is all again Vertex animations. Yeah, so that was it for this talk. I hope you enjoyed it, and I hope you learned a few new things here about either procedural level building, or how to make something like a simulation and importing that into Unity. So that was it for me, and if there are any questions, feel free to ask them.